Hello Maths fans, welcome back, and another help video for Maths Watch. This is from a Year 9 assignment, question 23, also relates to clip A14, A, B and C. I don't know which one this one's on, but anyway, it's all to do with gradients and equations, plotting straight line graphs, gradients and equations of straight lines. So in this one we're asked to find the gradient, the equation, of the blue line. Now, every straight line is made up, equation is made up of this structure here. It's y equals something times x plus something. Okay, now that's something times x. The something is called the gradient that multiplies the x, and the something at the end is called the y-intercept. And it comes from the word interception. We'll come to that in a minute. The letters given to this, if you'll see in videos, is m for the gradient and c for the constant, or the y-intercept for the gradient, the intercept. That's the easy part. Okay, so let's do that bit first. The y-intercept, you simply look down the y-axis and see where the line intercepts it. Intercept means their paths cross. So look, it's here, look, can you see? The y-intercept is at -3. So straight away, I can write my graph equation is y equals mx minus 3. Now that will get you a mark. That will get you a mark. Now we need to find the gradient. Let's get this value of m here. Okay, so let's just do a little subheading here, gradient. And you know, you've had a bit of practice with this at the moment. We know the gradient is how quickly the line rises for every 1 unit horizontally. So we can do it in both methods here. Okay, so if I go from -3, as it's a nice place to read from. If you look, we've got the line crosses perfectly on the grid here. Okay, I go horizontally 1. How far vertically does it go? It goes 1 unit, 2, 3, 4 units. Straight away, I've got a gradient is equal to 4. So y, taking this down here, y is equal to 4x minus 3, where my gradient is 4 and my intercept is -3. Okay, somebody might be saying then, well, hold on, this doesn't always work this way because sometimes I can't read off the vertical in whole units. Well, let's just try the other method that we could use here. And actually, in this case, we're not able to because there's nowhere else to read it from. So we are actually stuck with this method here. But vertical divided by horizontal is what we'd actually do. It just so happens in this case, the gradient will be equal to vertical divided by horizontal. The only two places on this line that we can read clearly, can you see what I'm saying by this? Look, maybe that one there, maybe. Let's have a look. Yeah, possibly we could use that point. Let's do that one then. Okay, so this point here, that was a good point to read from, and so was that. Okay, so I'm going to use these two endpoints just to show how we can use the vertical divided by horizontal in a slightly different way. So I'm trying to get from this point to this point here by first going horizontally, then going vertically. How far horizontally? That's 2 units horizontally, and to get up to that vertical point there, I'd have to go 1, 2, 3, 4, 5, 6, 7, 8. Just bear in mind, you have to check that each square is worth a unit on the y-axis when you're climbing. Sometimes that is not always the case, but in this case it is. So we've got horizontal is 2, vertical is 8. So I've put this in there, I get 8 divided by 2. Vertical 8, horizontal 2, which is 4, which confirms what we had already. So the final answer here, y equals 4x minus 3. I hope that makes sense, and I'll see you next time.